Very warm greetings, my dear friends. In this video, we are studying about continuity of the function. Consider this graph. This is a graph of the function y equal to fx. Suppose here we have 1, x value 1, corresponding fx value also 1. So this is a point on y equal to fx. Here, the f of 1 value is defined. F of 1 equal to 1. F of 1 value is defined and there is no break. There is no break in this graph. Similarly, suppose here 4 I am taking, corresponding point on y equal to f of x graph is this, and here also there is no break. So at x equal to 4, fx is continuous. At x equal to 1, fx is continuous. But here you have to see x value 2, there is a break here. There is a break. There is a gap in the function, graph of the function. So at x equal to 2, the function is discontinuous. Okay, so consider this graph. At x equal to 1, I am considering, here there is no gap. At x equal to 0, I am considering, here there is no gap. But x equal to 2 here, it is not defined. It is undefined here. X equal to 2, the corresponding value is undefined. F of 2 value undefined. Similarly, x equal to minus 1, f of minus 1 value is undefined. Okay, so here white circle, blank circle if we have, then we can say it is undefined. So if the graph is given, we can easily check the function is continuous at the particular point or not. Suppose graph is not given, the rule form of the function is given. How we are checking whether the function is continuous or discontinuous? Suppose y equal to f of x be a function in rule form. Using the limits concept, how we are going to find out whether the function is continuous or discontinuous at the particular point. A function is not given here, we are taking fx. A function fx is continuous at a point x equal to a. A function fx is continuous at a point x equal to a. If and only if the following three conditions are satisfied. So function is continuous means the function should satisfy three conditions. What are the conditions? First, f of a is defined. We can find out the value of a, f of a. So f of a is defined. First condition. Second condition, limit f of x when x tends to a exists. And third condition, limit x tends to a f of x is equal to f of a. So any one of this condition fails, then we can say the function is not continuous or discontinuous. And the second condition, you have to see what is the meaning of this. Limit x tends to a f of x exists. What is the meaning of this? Left limit and right limits are equal. So what is the meaning? Limit x tends to a minus fx is equal to limit x tends to a plus fx. Okay, so limit x is between left limit and right limits are equal. So using this idea, now we are going to check the given function is continuous or not. And if the function is continuous, find the missing value. So two types of problems we are going to concentrate in this video. Friends, consider this problem. If the function fx equal to fx taking two values, two valued function, x square plus 3x plus 2 by x plus 2 when x not equal to minus 2, and fx equal to k when x equal to minus 2. The function is continuous everywhere. If the function fx is continuous, then find the value of k. So what is the value of k? We have to identify. So function is continuous here. So continuous at every point. So in particular, fx is continuous at x equal to minus 2. So how I am selecting minus 2? Using this concept. Here x not equal to minus 2 and x equal to minus 2. No. So from this I am selecting. At the particular point, that point is minus 2. So I am taking a equal to minus 2. What is the third condition in our rule? So first condition is continuous mean first condition f of a defined. Second condition limit x tends to a fx exist. Third condition f of a equal to the limit. So this is our third condition. So here a equal to minus 2. So f of minus 2 equal to limit x tends to a value minus 2 fx. What is f of minus 2 value? F of minus 2, f of x equal to k when x equal to minus 2. So when x equal to minus 2, f of x equal to k. So left value I have k. Right value you have to see the limit x tends to minus 2. X is approaches to minus 2. So what is the meaning of this? X is not equal to minus 2. X is approaches to minus 2. So x not equal to minus 2 case I am considering. So what is fx value? Which is x square plus 3x plus 2 divided by x plus 2. So how we are finding limit of this function? We already studied in the previous video. So using that, how we are finding this, you have to factorize this. So I can write here, limit x tends to minus 2, we can factorize, which is x plus 2 multiply x plus 1 divided by x plus 2. So this x plus 2, this x plus 2, I can delete. I can write here k equal to, left side is k, limit x tends to minus 2, what is remaining is x plus 1. So direct substitution, x replaced by minus 2 plus 1, so which is equal to minus. So your answer is k equal to minus 1. Dear friends, consider this problem. If the function gx equal to gx taking two value is continuous, then find the value of k. So which rule we have to choose for finding the value of k? There are three rules we are having now for continuous function. So first one is fa is defined, but here the function is gx, so ga is defined. Second one is limit exists. Third one is ga or fa. Ga equal to the limit. So what is the a here? How we are selecting the a here? Take a equal to, what is the value, end value of the first interval and the first value of the second interval, both are same here. Okay, so that value we have to take as a. So a equal to 3. What is the rule? Here function is gx, so I am taking in place of fx gx here. So what is the rule here? Left limit and right limits are same. Limit x tends to a minus fx, usually we are writing, but in this problem the function is gx, I am writing gx equal to right limit, limit x tends to a plus gx. So now a replaced by 3. 3 minus jx equal to limit x tends to 3 plus jx. How we are finding the left limit? Earlier videos we studied. I'm using that. So I'm finding the left side value. So limit x tends to 3, but 3 minus here, I'm writing 3 only. What is the value of gx? 3 minus mean, recall, 3 minus mean, suppose 3 is here, x is here, x approaches to 3 from left side. It is the meaning of 3 minus. So x value here less than 3. X value less than 3 means here available. What is the value of gx? Gx equal to square root of kx, which is equal to this side right limit. Limit x tends to 3 plus, I am writing 3 only, but 3 plus means corresponding gx value. So again the same idea, 3 is here, x is approaches to 3 from right side. So what is the meaning of this? X is greater than 3. X is greater than 3 mean here x value is more than 3 mean gx value x plus 1. Now direct substitution, left side x replaced by 3. So square root of 3k, x replaced by 3 equal to, here x replaced by 3 means 3 plus 1. Square root of 3k equal to 3 plus 1 is 4. From this, we are finding the value of k. So squaring on both sides, here we have 3k and here 4 square is 16. So k equal to 16 by 3. So this is our k value. It's clear. Friends, see this problem. If the function gx equal to e power kx, when x lies between 0 and 4, and gx equal to x plus 3 if x lies between 4 and 8. The function gx is continuous, then find the value of k. Same idea as in last problem. So what is a value here? We have to take, like last problem, here take a equal to, so here 4 available, here also 4. So I am taking 4. What is the rule? Recall the rule. Left limit and right limits are equal. So limit x tends to a minus, here function is g of x. So g of x equal to limit x tends to a plus g of x. So here a value 4. So limit x tends to 4 from left side. So 4 minus g of x equal to limit x tends to 4 from right side, g of x. So how to find out this limit? Limit x tends to 4 minus or 4. Here I am writing 4. So what is gx value? 4 minus means x value is less than 4. X value less than 4 means gx value equal to e power kx, which is equal to limit x tends to 4 plus x tends to 4, gx value 4 plus means x value more than 4, so which is x plus 3. Just we are finding both the limits, get the value of k. So here by direct substitution, e power x replaced by 4, so 4k equal to, here x replaced by 4, 4 plus 3 is 7. So get the value of k. How we are getting e power 4k equal to 7? How we are getting the value of k? Both sides we have to take logarithm. So I have to introduce logarithm both sides. Log of e power 4k equal to log 7. Natural logarithm we are introducing both sides. Okay, logarithmic function and exponential function both are reverse function, inverse function. Okay, so logarithm exponential, if we are taking at the same time, it will be deleted. So I can delete logarithm and exponential function. We are having this side 4k only and this side log 7. So k equal to log 7 divided by 4. So what is log 7 divided by 4? This value we can find out easily, 0.486. So k is 0.486. Now we have to consider the function hx equal to 3x plus 2 if x greater than 4. If x less than or equal to 4, hx equal to 2x minus k. If the function hx is continuous, then find the value of k. Same type of problem. So what is a value here? A equal to, here x is greater than 4, here x is less than or equal to 4. So I'm taking a equal to 4. As usual, we are writing the rule. Left limit and right limit are equal. Limit x tends to a from left side, a minus. Here h is a function, so hx equal to limit x tends to a from right side, h, left limit and right limit are equal. So here a equal to 4, limit x tends to 4 minus hx value equal to limit x tends to 4 plus hx. So we know how to find out the limit. So limit x tends to 4. 4 minus mean x value is less than 4. X value less than or equal to 4. The corresponding value of hx is given 2x minus k. So this side value 2x minus k equal to limit x tends to 4, hx value 4 plus mean x value is more than 4. So hx equal to 3x plus 2. Now direct substitution. X replaced by 4 here. 2 times 4, 8 minus k equal to, here x replaced by 4. 3 times 4. 3 times 4 is 12 plus 2. So 8 minus k equal to 14. So k equal to 8 minus 14. So k equal to 8 minus 14 is minus 6. Consider the problem here. Verify the function fx equal to 2x square minus 5x plus 3 divided by x minus 1 is continuous at x equal to 1. One function f of x is given and x equal to a. Here a is 1 is also given. How we are checking f of x is continuous at the point x equal to 1? We have three conditions for checking f of x is continuous or not. First one is f of a defined. Second one is the limit x tends to a f of x exists. And third one is f of a equal to limit x tends to a f of x. So we have to check every condition one by one. If all the conditions are true, then we can say f of x is continuous at the given point x equal to 1. Suppose at least one condition fail, then we can say f of x is discontinuous. So here a equal to 1. So first condition we are going to check. What is f of a value? F of a equal to 1 here, so f of 1. Fx equal to 2x square minus 5x plus 3 over x minus 1. So just x replaced by 1 here. So 2 times 1 square minus 5 times 1 plus 3 divided by 1 minus 1. Numerator value got to see 1 square is 1. So 2 minus 5 plus 3 divided by 1 minus 1. What is the numerator? 2 minus 5 minus 3, then plus 3, it is 0. 1 minus 1 is 0. 0 by 0 means indeterminate form, undefined here. So f of a is undefined. So first condition fail. So immediately we can say f of x is discontinuous. So f of x is discontinuous. Now here another one function, we are checking the function is continuous or discontinuous. Here fx equal to x sin x when x less than or equal to pi, x tan x, x greater than pi. We are checking the function fx is continuous at x equal to pi or not. So what is the a value here? A equal to pi. At the point x equal to a, we are checking f of x is continuous or not. So a equal to pi here. First condition I am checking. Condition 1. F of a defined or undefined. So I am finding f of a value. F of a equal to, here a is pi. So f of, what is f of pi? You have to check. Fx equal to two values, x sin x or x tan x. When x sin x, x less than or equal to pi. Fx take value x sin x. So if x equal to pi also, x sin x. So in this x sin x, I replaced x by pi. So I can write x replaced by pi. Pi times sin pi. Sin pi value is 0. So 0 times anything, 0. So it is exist. F of a exists. First condition hold. It is true. Now check for second condition. What is second condition? Limit exists. Limit exists means left limit we have to find out. Right limit we have to find out. Both are same. Then limit exists. Okay, so second condition we are going to check. So I am finding left limit. So limit x tends to a minus fx value we are going to find. So a value is here pi. Limit x tends to pi minus fx value. So left limit how we are finding? Limit x tends to pi fx value. What is fx value? X tends to pi mean x value less than pi. Less than pi. Okay, so what is fx value? How to see? X sin x. Here x replaced by pi. Direct substitution. Pi times sin pi. Sin pi equal to 0. So pi times sin pi is also 0. So left limit we found. Now we can find out the right limit. So limit x tends to a plus fx equal to a value pi here. Limit x tends to pi from right side fx. How we are finding the right limit? Limit x tends to pi. What is value of fx? Pi plus mean more than pi. So more than pi mean x greater than pi. Fx value x tan x. So x tan x. Now by direct substitution, x replaced by pi, x replaced by pi. So x times tan pi. Tan pi is 0. So pi times tan pi is 0. So left limit and right limit, both are same here. So limit exists. This implies limit x tends to a, f of x equal to 0. Second condition, okay. We found that limit exists here, the value is 0. Now, third condition. What is the third condition? Limit x tends to a, fx equal to fa. Is it true? Yes. Here, f of a equal to 0. Limit is also 0. Both are equal. So, third condition also true here. So, that is third condition. Limit x tends to a, fx is equal to f of a. So, from the condition 1, fy equal to 0, and condition 2, limit x tends to a, fx equal to 0. Both are same. Hence, fx is continuous. Hence, fx is continuous at x equal to pi. Consider this problem, friends. Verify the function g of u. Previous all the problems we are having x as a variable. But here u is the variable. So g of u equal to two values we have. When u equal to 1 by 2, we have 7 by 2. U not equal to 1 by 2, we have the function 6u square plus u minus 2 divided by 2u minus 1. We are going to check the function g of u is continuous at u equal to 1 by 2 or not. So here we are taking this our a value 1 by 2. 1 by 1 we have to check. So I am checking first condition, g of a is defined or not defined. A equal to 1 by 2. So g of 1 by 2, u replaced by 1 by 2. So when u equal to 1 by 2, so g of u is 7 by 2. So g of 1 by 2 equal to 7 by 2. G of u equal to 7 by 2. It is defined. First condition, okay. So go for the second condition. We are checking the limit exists or not exist. So limit exists means usually we have left limit and right limit we are checking. But this you have to see, u not equal to 1 by 2, we are having only one value. Whether u is less than 1 by 2 or more than 1 by 2, g of takes only one value. So directly we can take for the limit constant. No need to go for left limit and right limit. So what we can write? Limit x, here u is the variable, u tends to a, g of u we are going to find out. Usually we are having x tends to a, fx. According to the function and according to the variable, we are writing here like this. So limit u value 1 by 2, u tends to 1 by 2. What is g of u value? The value is given here, 6u square plus u minus 2 divided by 2u minus 1. If we are going for direct substitution, you have to check we are having indeterminate form. So what we have to do? You have to factorize the numerator. Using AC method, you can factorize. So how to factorize, we know that. So I'm writing directly. This value, numerator value, is 2u minus 1 times 3u plus 2. Easily you can check this using AC method. We can factor in the numerator divided by 2u minus 1. So this 2u minus 1, 2u minus 1 I can delete equal to limit u tends to 1 by 2, 3u plus 2. So u replaced by 1 by 2. 3 times 1 by 2 plus 2, which is equal to 7 by 2. So from condition 1 we have g of a equal to 7 by 2 and limit u tends to 1 by 2 or u tends to a, g of u is also equal to 7 by 2. So from condition 1 and 2 we can check the third condition, limit u tends to a, g of u, it is same as g of a. So condition 3 also true. So this left value is 7 by 2, right value also 7 by 2. Hence g of u is continuous at u equal to 1 by 2. Thank you for watching this video.